Good morning all, my name is Alex, and in less than 10 minutes, we'll discuss how we build this Copilot application with the help of generative AI for digital twins, where the physical world meets the digital world. So in this case, this is the value proposition of building immersive 3D visualizations alongside with the generative AI copilots based on a common representation of 3D objects using USD and USDA formats. USD is the universal scene description, and USD is the ASCII variant of USD. This is the overall solution architecture. And if you look at this, we implemented two prompt flows and two orchestration flows. One, the classic chat completions, and another one is the RAG workflow, which is the retrieval augmented generation workflow. We used a static web app built in React.js. And as you can see, we leveraged Azure AI Search as a vector index. So first of all, let's pick up an example. Like in this case, this is the architecture visualization in Unreal. It has this building, and we're looking at Unreal. We installed NVIDIA Omniverse plugin here. And what we're going to do, we're going to review this specific building that we're interested in, and also connect to our local Nucleus server, and then export essentially the USD representation of this building into a USD file, and put this in our Nucleus server right here. This building consists of multiple meshes, different representations of materials, and this is pretty much like, to begin with, this is what we're interested in. To export, you export to Omniverse, include what you want to include, including materials, including some other scene components, and then you get the USD file. Great, so USD file is the common foundation, and USD file also goes around multiple different 3D software, and it's interoperable. So in this case, we're looking at USD Composer as a part of NVIDIA Omniverse, and we're picking up this USD file. And you can see that, again, we can, in this case, we're going to put this in Babylon.js for the visualization. And because USD format is interoperable with any other formats prevalent in the industry, in the 3D and modeling space, we can save this or export this as a different format. For example, GLTF-GLB, this is what we interested in particular, for this to be displayed and for this to be rendered through Babylon.js in our React.js app. And you can also see that, again, there's a way for us to save this as USDA. So USD is the ASCII representation of USD, which helps us to set up our generative AI copilot to basically be knowledgeable about the structure of this specific building. Before we proceed, so we're looking at Blender now, and we're gonna flatten that structure just for simplicity, and also play a little bit with materials just to make sure that we display glass as we want this to be displayed, a little bit more kind of fancier. But for the most part, again, we review the structure of this specific building and look at its structural components, look at floors, walls. And then you can see that, again, interoperability of USD format and how in Blender you can open this up, and you can open this up in any kind of application and do some additional post-processing if you wish to do so. Here's the building. It has, in flattened representation, it has 156 meshes, different kinds with assigned materials. And just for simplicity, we remove the world component node as well as the and just left basically, and as well as the root, and then just left basically those core meshes. What's interesting, you saw that the floors are numbered in a specific way, and we'll come back to that. In terms of USDA, if you open this up in just as simple as Notepad, you will see that this is the representation of the USDA. So we're interested in different types of meshes, and then also material bindings assigned to those meshes. So based on that, we can have a lot of intelligence around like how this building is built, what it consists of, and we can ask some intelligent questions and get some intelligent answers. So there's the floor for one with the material bindings of different kind and so on. So to orchestrate our chat completions, we used prompt flow, which is a part of Azure Machine Learning. So first, prompt flow is just a simple chat completion. And what's interesting is that you can use, for example, function calling in this case. If you see, we embedded the structure of our building into the prompt, but technically you can put, for example, your models into Azure Blob Storage. You can put your definitions of your USDA definitions of your models into Cosmos DB, and then here in prompt flow, by means of functions calling, you can basically pull it in based on the ID of the building that you're working with. But to keep it simple for this presentation, we just have this as a part of the prompt with a few short learning, just providing the example of what you have to expect, and then the actual building format, as well as we implementing the command, which is one more feature that you can get implemented with prompt flow and with generative AI. So it will be able to interpret your commands and organize some interesting interaction. For the second flow, we implemented RAG, the retrieval augmented generation pattern. And the best way to begin with RAG in prompt flow, in our opinion, is to begin with vector index. So you have your documents. We have markdown documents, PDFs, and some other documents. So we created this vector index. And then once we created vector index, ML took care of the chunking, building embeddings, creating the index. And then you see this example prompt flow. And if you choose to go with this based on that vector index that you created, it gives you right away the fully functioning RAG pattern implemented as a separate prompt flow, which is pretty great. So then if you look at components of it, this is, again, it's going from receiving arguments from your request, basically using one of the standard embeddings models to convert your input into embeddings, and then kind of retrieving the information of your choice, and then basically providing you the answer for your question with the context based on the RAG. So this is just a great way to get started with RAG pattern, RAG prompt flow in prompt flow. So that's our second prompt flow that is taking advantage of RAG. Then we basically use those prompt flows and deploy them as endpoints. Once you deploy them as endpoints, then there's a consume tab that you can look up the key-based authentication for your endpoints. And then we took it forward because just to demonstrate that security is important, we took it forward and we basically wrapped these calls into these endpoints with the Azure API management. And that's exactly how this works. So we took those keys and we made sure that only API management is capable of calling those scoring endpoints in AML and nobody else. And then our React.js application goes through API management, which provides advanced security such as web application firewall and throttling and load balancing and many other goodies that just a best practice for you to use. And then, so this is just a quick example of how you invoke our intelligence through the API management. So this is what allowed us to build the template, the sample that we described in GitHub. You can see this is working, and this is the overall big picture of different immersive experiences you may want to build. And you can read more in our Medium article. Thank you.